In number 23 through 26, we're asked to decide whether the statement is true or false. So the graph of a rational function can have both a vertical and a horizontal asymptote. That's true. The parent graph would be a perfect example of one that has both. The graph of a rational function can have both a vertical and oblique asymptote. That is also true. And then the graph of a rational function can have both a horizontal and oblique asymptote. That is false, because remember, you do long division, either synthetic division or polynomial long division, to find your horizontal or oblique asymptote, and there can't be both, right? It's either going to be one or the other as a result of that division. So then in number 26, the graph of a rational function can have both asymptotes and holes, and that's true. Holes come from factors that cancel from the rational function. Asymptotes come from the what's left. So this would be true. And then looking at the section at the top of the next page, right, number 27, 2x squared minus 17x plus 21 divided by x minus 7, and we want to know where is the hole in that graph. So I need to factor excuse me, that numerator. So I'm looking for factors of a times c, which would be 42, that add to equal b, which is negative 17, and that'd be negative 14 and negative 3. And then I can organize my terms in a box to factor. So first term in the first box, 2x squared. Last term in the last box, that's the constant 21. The remaining two boxes get my factors from the crisscross, so a negative 14x and a negative 3x. And then going across the top row, 2x squared and negative 14x have a 2x as their GCF. Negative 3x and 21 have a 3 in common. 2x squared and negative 3x have an x, and negative 14x and 21 have a 7. Since the diagonal is negative, both of these factors are going to have a minus in the middle, and so my factored form is 2x minus 3, x minus 7, and then the denominator was x minus 7. So I can see that my factor of x minus 7 cancels from the numerator and denominator, and that's what forms the whole. So at 7, I have the x-coordinate of my whole, and then to find the y that goes with it, I put that 7 back into the simplified form 2x minus 3, and 2 times 7 is 14, minus 3 is 11. So the whole in the graph is at the point 7, comma 11. Okay, then in number 28, my numerator as a difference of perfect squares, x squared minus 16, that factors as x plus 4, x minus 4. The denominator is a perfect square trinomial, so x squared plus 4x plus 4, that factors as x plus 2, x plus 2. And zeros come from the numerator. I set each factor in the numerator equal to 0. So negative 4, comma 0, and positive 4, comma 0 are the x-intercepts. The y-intercept comes from putting 0 in for my x's and solving for y. So 0 plus 4 times 0 minus 4 would be negative 16. 0 plus 2 is 2, and 2 times 2 is 4. Then negative 16 divided by 4 is negative 4. So 0, negative 4 would be the y-intercept. Okay, then looking at number 29, this denominator x squared minus 49 is a difference of perfect squares. That would be x plus 7, x minus 7. Vertical asymptotes come from non-canceled factors in the denominator, so we would set each of those equal to 0, and x equals -7 and x equals +7 would be vertical asymptotes. Okay, the horizontal asymptote, remember Bobo Botan eats DC, so the Bobo is bigger on bottom 0, and since the degree of our denominator is bigger than the numerator, y equals 0 is the horizontal asymptote. Okay, then looking at number 30, to find the horizontal asymptote, if I'm using Bobo Botan eats DC, that shortcut, now this one applies to the eats DC. Exponents are the same, divide coefficients. So we have 10 divided by 5 is 2. So y equals 2 would be the horizontal asymptote.